11.3.3 Combinations. Essential question. When would combinations be used and how is it calculated? Skill. I can use counting techniques to find the number of combinations or permutations of something. Eric spins a spinner 7 times. The choices the spinner can land on are red, green, blue, and yellow. The order of the colors land on do not matter, and he could get the same color more than once. How many possible outcomes are there? So we have a spinner with 4 equal choices. Red, green, blue, and yellow. And it was 7 times. The order doesn't matter here. And it's with replacement. Because, I mean, when you spin it, the yellow's not going to just disappear if it gets chosen. There's a combination. If we refer to our booklet, it's going to be the second to last formula. R plus n minus 1 factorial all over r factorial times n minus 1 factorial. Where n is the number of things to choose from, we choose r of them, repetition is allowed, and order doesn't matter. Let's identify n and r. If we refer back to the booklet, n is the number of things to choose from. There are 4 possibilities. And then we're going to spin it 7 times. So that's how many we choose. From there, we'll plug it into the formula. 7 plus 4 minus 1 factorial all over 7 factorial, 4 minus 1 factorial. So we have 10 factorial over 7 factorial, 3 factorial. If we write these out, we get 10 times 9 times 8 times 7 factorial, and then 7 factorial, 3 factorial. The 7 factorials can cancel out. That's why I didn't expand them anymore. 3 factorial is the same thing as 6. So we could take a 3 out of this one. We could take a 2 out of this one. So we'll have 10 times 4 times 3. 120 outcomes. Susan goes on a trip for 3 days, so she will take 3 shirts with her. If she is picking from 8 shirts, how many combinations of shirts can she take? On this one, the order doesn't matter here. And the shirts aren't going to regenerate, so there's no replacement. This is a combination. If we refer to the booklet, it is the last formula on this page. Combinations without repetition. N factorial over r factorial times n minus r factorial. Where n is the number of things to choose from, we choose r of them, no repetition, and order doesn't matter. It's often read as n choose r, and also known as the binomial coefficient. Let's identify our n and our r. R is how many we're choosing. There's 3 days and she chose 3, so that's going to be R is 3. N is the number of things to choose from. We could choose from 8 things. When there's no replacement, N has to be those smaller than r. Now with replacement, there can be cases where n is smaller than r, such as in the spinner example above. If we plug this into the formula, we get 8 factorial over 3 factorial, 8 minus 3 factorial. So that's 8 times 7 times 6 times 5 factorial over 3 times 2 times 5 factorial. The 5 factorials cancel out. 3 times 2 is 6, so those cancel out as well. 8 times 7 is 56. There's 56 outcomes. Answer the essential question, and then try the examples below.